Hello and welcome to the first lecture of our MongoDB Beginners Bootcamp. My name is Mark and I am your instructor for this course. First, let us begin with a brief introduction to MongoDB, and immediately in video 2 we will begin working one-on-one with MongoDB in the live platform. First, let's take a look at MongoDB and some of the history behind it. MongoDB was created by Dwight Merriam and Elliot Horowitz, who had encountered development problems when working within a traditional relational database. Some of the problems, or the main problem they encountered, was how to store big data. Big data that is not normally accepted into a structured or a relational database. Ultimately, they implemented MongoDB, which is an open source database management system that uses a document-oriented based model to support various forms and large amounts of data. MongoDB is classified as a NoSQL database, which stands for Not Only SQL, and is used in big data applications and other processing jobs involving data that does not fit well into a structured database. There are three main important features of MongoDB. These are the features that make MongoDB stand out and makes it a unique database. The first is flexibility. With flexibility, you can enforce any type of data within MongoDB. Data in MongoDB has a flexible schema. Collections do not enforce document structure. This flexibility gives you the data modeling choice to match your application and its performance requirements dynamically. Therefore, it can dynamically modify the schema without any downtime to the database. Scalability. Scalability means that we should be able to meet the consumption of a growing database. It can be defined as the ability of the system to handle a growing amount of workload in a capable manner. As the size of the data increases in MongoDB, a process called sharding solves the problem by doing horizontal scaling. Performance is a very important factor when dealing with a database in MongoDB or with any database, relational or non-relational. MongoDB performs well. The reason for this is that the number of queries can increase SQL to take more time to execute those queries when working within a relational database, but the performance factor of MongoDB is better in such scenario. There's no various factors that are responsible for the high performance of MongoDB. Provides the embedding of documents. It avoids the concept of joins, which is a complicated matter when working within a relational database, and it provides us the ability to index data. MongoDB also uses JSON. JSON stands for JavaScript Object Notation. JSON-like documents means that fields can vary from document to document, and data structure can be changed over time. This is not an option that is easily done within a relational database. JSON supports all of the basic data types you'd expect, such as numeric, strings, and booleans. MongoDB represents JSON documents in binary encoded format called BSON behind the scenes. BSON extends the JSON model to provide additional data types, order fields, and to be efficient for encoding and decoding within different languages. Let's take a look at a relational database, and let's take a look at how the difference that it has compared to MongoDB. So first, before we take a look at any relational database, let's take a look at the terminology that MongoDB uses. So MongoDB is still referred to as a database. As with relational database management systems, a database is the proper term straight across the board. However, unlike a relational database that uses the term table for their tables, in MongoDB, a table is referred to as a collection. and a collection is not structured the same way as the average table in a relational database. We will see an example of this in the next slide. Index are the same in a relational database and MongoDB. A row is considered a document in MongoDB. A column is considered a field. And joins in a relational database are normally done by inner joins, outer joins, left joins, right joins, or sometimes subquery joins. However, in MongoDB, the concept of joining tables together or collections together are completely different. We create relationships, and within those relationships, we create embedded information. We then link that information together, and we use different functions such as lookup or graph lookup to retrieve data from within a collection. We will have a lot of practice with this in the coming lectures. Now let's take a look at a relational database. This is a simple format of a relational table from a relational database. And here is how we create a table. This is what a table will look like in a relational database. Normally there's a field, and one of the fields has to be a unique identifier, a primary key. As you can see here, we have the employee ID, which is the primary key. We have name of employees, and we have title of employees. To create a table in a relational database, we must use the create table statement. We must select a name for the table, and we must identify the name of each column. In addition, we must select a data type and a size for that data type. Once we select the data type and the size for that data type, all of the information inserted into the table must meet the requirements, or else we will be prompted with an error. For example, insert the first row, employee 1, Jones, manager IT. We are selecting a number, therefore there's no quotes, and we're entering a varchar. A varchar for name up to 30 characters, therefore whatever we enter must be 30 or less, and a title up to 25. Anything we enter here must be 25 characters or less, including the spaces. Anything above will prompt us with an error. If we try to enter anything else, any other type of data types in these fields, we will be prompted with an error. What do I mean? Therefore, employee ID must be numeric. Name must be varchar. Therefore, for the name, if we set up the structure of the table to be varchar or numeric, when we enter the information, it has to be varchar or it has to be numeric. Suddenly, we cannot make this a different data type because the structure of the table has already been formed, and the system knows this. Therefore, if we were looking to change the table, we will have to drop the entire table, delete the table, and repopulate the table. Now let's take a look at how this exact table is created in MongoDB, what it looks like in MongoDB, and how easier it is to work in MongoDB. So before we switch to the next slide, pay attention to this information. We have employee 1, 2, and 3, Jones, Smith, and Green. Here's what that looks like in a MongoDB. First, to create a table or a collection in MongoDB, we must select the name of the collection. Therefore, the name of the table in the relational database was employees, and we want this information to be identical in our MongoDB system. We want the information to be identical so you can see and understand, okay, the information is identical, but it's different how we insert the information and how we work with the information. So let's take a look here. First, to create the table, you use the use command. Use command followed by the name of the collection. Therefore, I typed in use employees because that is what I would like my collection to be named. Then I can insert each one of those employees, we had 3, one by one. Insert the employee ID, the name Jones, and the title for each employee. And if each employee is inserted successfully, we will have an output that says "and inserted 1." And this means that it was successfully inserted into the database. Now, when we insert information into the database, we can look at that information the same way we can look at the information in SQL. Normally in SQL, we can select star from the name of the table, and all of the information will be provided to us. It is the same thing in MongoDB. To view the information within a collection, you can use the DB period collection name period find open parentheses, and this will list us all of the information inside of the database, inside of the collection. We can also do db.collectionName find open parentheses period for each document within the collection print in JSON format. And what that means is the data will be returned to us exactly the same, except the data will be returned to us in this format, where it's a little more easier to read. So this is what the formats looks like when we use for each print JSON. In the next few slides, I will show you an example of what the data looks like when we just do db.collectionName find. It's the same data, but it's clustered and it's a little harder to read. Now also, we can also insert data into the collection in different ways. First, we inserted information about employee 1, 2, and 3, and we inserted that information separately. We can also do a bulk insertion into a Mongo collection. What we will do is we can create a var. As you can see, I did here. I created a var, named it my employee var, equal to, within brackets, and then for each document you would like to add, I am adding 3. I am adding employee number 4, employee number 5, and employee number 6. Each document is separated within their own curly brackets. Each document is also separated by a comma. This is how we know we're at the end of each document. So here starts another document. The information we're looking to add, the closing bracket, comma. New document, the information we're looking to add, closing bracket, comma. There's nothing else we would like to add at this time, so we can close the bracket, semicolon, and then we can enter this information into the MongoDB all at once. And we do this by using the insert command. As you look at the bottom image, I have db.employees, which is the collection name, dot insert, in parentheses, the name of my collection. The name of my collection was my employee var, and I'm identifying the collection I created right here within these parentheses, semicolon, and you will hit enter. Once you hit enter, if there's any errors, it will tell you right here on the platform. But we were not provided with any, or we were not outputted any errors. Therefore, everything was inserted fine. 3 documents were inserted. Now here's what the database looks like. Now that we've inserted 7 different employees, actually, I've inserted a 7th, but so far we have only inserted 6. Let's review the 7th. And here it is. It's right here. So first we had employee ID 1, 2, and 3, and we inserted those separately. Then you created a var, or we created a var in this example, and we inserted employee 4, 5, and 6. However, I inserted employee 7. And I did this on purpose, and I did it a little different to show you how MongoDB is willing to accept changes within a collection or within a table, as to where we will not be able to do this in an SQL database. So here's what I did. I inserted employee number 7. And I inserted a name for that employee. But when I inserted that employee, all of the other previous times, I used quotes for the first 3. For the second 3, I just entered a number. And then for employee number 7, I also used quotes around the value. Normally in SQL, if we're using a numeric data type, you do not have to use quotes. Also, you will use a numeric data type if you need to conduct some type of calculation within a database. Therefore, if you have a numeric number that you need to conduct calculation with, you should not use a variable in SQL. Therefore, the system will not be able to calculate anything. Also, for employee number 7, I left out the title. And I left this out on purpose to show you that MongoDB will accept the document that I've entered, even if it's in a different format. We have the name, or one of the fields are missing. They will still accept this information. Working with SQL, we will not be able to do this. The only time in SQL we will be able to leave out a field is if we have the option to do that. And we will know if we have the option to do that is by looking at the structure of the table again. Everything says not null. Anything that says not null means that information is required. It is mandatory. However, if there's no indication of not null, then that field is optional. Only then can we insert information or not insert information for that column. And SQL will accept it if we have the option to leave it blank. However, if we do not have the option to leave it blank, and we are told not null for every single line, we must always enter information in that field. And that is just a difference in MongoDB, as you can see here. So in MongoDB, for all of our employees, 1 to 6, we have the employee ID, we have their name, and we have their title. But for employee 7, we just have the employee ID and the employee name. We do not have a title for him, and the system was perfectly fine with us entering information that way. In fact, if we were to enter other information into the system, even add a field besides name, employee ID, or title, let's say we add a field that says date hired, the date the employee was hired, MongoDB will accept the statement and add a field for that specific table. Now, this is just a brief explanation of how the database accepts data and how data can be stored either in a relational database or a MongoDB, a NoSQL database. Also, here's the example of what the output will look like if we view data simply using the find command. db.collectionname.find will give us a list of all of the employees in a straight format. But as you can recall, here I used the example of db.collectionname.find for each print JSON, and this prints out the information in a little more presentable manner. So in this video, we had a brief introduction to MongoDB, and we had an idea of how to create collections in MongoDB, how to insert data within a collection or document within a collection. We can insert it one at a time, or we can do it in bulk using the insert and by creating a var. In the next video, we will begin by actually working with MongoDB hands-on. Step by step, we will create 2 collections within a database. Then, towards the end, we will form a relationship within those 2 collections, and we will start linking those relationships to gather information the same way we will in a structured database, except we will not be using joins. The process is different, but it's very easy to grasp. So I will see you in the next video, and we will begin working hands-on with MongoDB. See you then. Thank you.